Okay, let's do another example for differential equation with initial condition. Y prime minus 5y equals to 1 is the equation, and the initial condition is y at 0 is equal to 3. Okay, so to do the initial differential equation with initial condition, we first need to find the general solution. First, find the general solution, and then in the second step we use the initial condition to find the particular solution for that differential equation. Okay, so first thing first, what type of differential equation is that? So note that this is y prime plus something times y, that something is -5, and then equals to another thing which has no y in it. So that means that this guy is px and this guy is qx, although they don't have any x, but the important point is that they don't have any y, and that does the step one for us, which is saying that this is a linear differential equation and px and qx are given. So note that this guy is a linear, first order linear differential equation. So we need to basically write it in the standard form, put it in the standard form, and identify px and qx. So here, well, we already did this, y prime plus -5 y equals to qx equals to 1. That means that px is -5 and qx is 1. Okay, then the step 2 is find the integrating factor. For that, we need to know the formula. U, the integrating factor, is e to the power integral of px dx. And for us, this is -5 dx, and that is e to the power -5x. That's the integrating factor. Okay, then the last step, now that you have the integrating factor, find the solution. The solution using the formula. What is the formula? Y, the general solution, is 1 over ux integral of qx e to the power, qx times the integrating factor. Well, always you get plus c here, but you have to be careful. You have to multiply it by 1 over ux. Here, let me just plug in everything. E to the power -5x. Integral of qx is 1, so I have 1 e to the power -5x dx plus c. And this is, well, I can bring this up. I can write it e to the power 5x. Then integral of e to the power -5x. You just do a very simple substitution, -5x to be u, then du is going to be -5 dx, and from there you can easily see that antiderivative is this guy plus c. Oops. Plus c. Well, then let's multiply this inside. So it is e to the power 5x times e to the power -5x over -5 plus c e to the power 5x. This and that cancel, and we get the general solution is -1 over 5 plus c e to the power 5x. Very nice. So we found the general solution. That's the first step. Now we want to use that one to find the particular solution. So we need to go to step 2. The second step is use the initial condition, which was what? The initial condition is y at 0 is 3. Y at 0 is 3. That means this is x, this is y. To find the particular. Okay, so let's just check this thing. So if I plug in y at 0, it is going to be negative 1 over 5 plus c e to the power 5 times 0. Oh, this is c. Okay. And this needs to be equal to 3. So I have negative 1 over 5 plus c times e to the power 0 equal to 3. That means that negative 1 over 5 plus c is 3. And then from there, you can see that c is 3 plus 1 over 5. That gives me 16 over 15. And that means that the particular solution is y equals to negative 1 over 5 plus 16 over 15 e to the power 5x. And this is the general solution, the particular solution for that differential equation with that initial condition.